Today's topic is dot plots and distribution shapes. Dot plot is a frequency plot that shows the number of times a response occurred in a data set where each data value is represented with a dot. Sometimes that may be different if you're given a key, and a dot may be worth more than one. So just look to see if there's a key. Constructing a dot plot. The following data represents the amount of money each student spent at the school store on Monday morning. Construct a dot plot for the data. So there's all the data that we are given. We're going to place a dot above each value in the data set. So the first dot we'll put above the $1, and then do a dot above the $5. A dot above the $3, and then you're going to need to stack another dot above the $3 above that. Make sure when you're doing this that your dots are spaced equally and they're the same size. This is what the dot plot should look like once it is completed. So $1 was spent by 2 students, 3 students spent $2, 5 students spent $3, 4 students spent $4, and 1 student spent $5. Example of reading a box plot. So we already have one made. The information is given there for us. How many students missed only one day of school? So look at the 1 and count your number of dots. There should be 6 dots. So there were 6 students that missed only one day of school. How many students missed more than 4? So now we need to count the dots for 5, 6, 7, and 8 absences. If we add those all together, there are 12 students. Were there more students who missed one day, which remember was 6 students, or 7 or more? So if we count out the 7 or more, that's 8. 8's bigger than 6. So there were more students that missed 7 or more days. Here's another one. We're analyzing a dot plot. It's already made for us. How many students spent $2? That should be 3 students. How many students spent less than $4? We need to count all the dots for the values of $1, $2, and $3. There should be 10. What dollar amount did the most students spend? So the value that has the most dots is $3. So more students spent $3 than any other dollar amount. Comparing two dot plots. We have temperatures. It's the daily low temperatures that are in degree Fahrenheit, city A, city B. Which city's temperatures vary more? So we're looking for the spread in the data, and it looks like city A has more variability in their data. We'll be doing more with variability later. Which city's temperatures seem symmetric? So if we were to find the middle and fold it up, the 2 sides would match up. You did symmetry in your geometry classes, and that would be city B. 2 more plots that we are comparing. There's values for exercise in hours and video games in hours, and there were students that were surveyed. In which activity do the students generally spend more time? Well, there's more dots at the higher values for video games. So the students generally spent more time on video games. How many students were questioned for each activity? So count the number of dots in each of the dot plots. There were 14 students questioned. Describing distribution shapes. This one is fairly symmetric, which we can also call bell shape because the highest peak is in the middle and then it tapers off to both sides. If you were to fold it, it would pretty much match up. It's not always going to be identical, but it's going to be very similar. A distribution like this is also symmetric, but it's not bell shape. This is U shape because the tallest bars, or the most frequent values, are on the far ends. This distribution is skewed to the right or right skewed. It may also be considered positively skewed. So there are 3 different terms you may come across as you're watching videos or looking in your textbook. All 3 of those would be considered correct if you had to name a distribution that looks like this. Here's the next distribution. Very similar to the last one. I just cut it off slightly so that it would be a different shape. It's still skewed to the right, but since its most frequent value is to the far left, it is considered L shape. Here's another distribution. This time the tapered off end, if we look at that over here, the lower frequencies of the values happening are to the left. This is skewed to the left or left skewed. It may also be called negatively skewed because on a number line, the more you go towards the left, you're going to be heading towards the negative values. This one is very similar to the last one. I just chopped off a little bit because that makes it a little bit different shape. The values still taper off to the left, so it's skewed to the left, but since its most frequent value is the highest value, it's farthest to the right, this is referred to as J shape. This one is bimodal. There are 2 peaks. They're about the same height. They're not always going to be identical, but they will be higher than the other ones. They're not on the far ends because that could be considered U shape. But there needs to be values in between that are lower. We do not have 2 of the highest values or frequencies right next to each other. That does not make it bimodal. Uniform distribution is what this one is. Each data value occurs approximately the same number of times. It looks very flat. They're all about the same. One more thing. We'll be doing more with stem and leaf plots in the next lesson. Here are a couple stem and leaf plots already created, and on one of your assignments you have some stem and leaf plots. The way that you can determine the shape of the distributions is to turn your paper so that it looks like this, where these are now along the bottom. And then you pretend each of those numbers are like dots, and you can figure out the distribution shape. So this very top one here is symmetric. The highest peak is in the middle, so that is about bell shape. The next one tapers off to the left. Okay, so it's skewed to the left, but since this has the most values in it and is farthest to the right, this is going to be J shape.